Alright, so next up we'll have a look at question 4. So 4a asks us to write down the amplitude and period of the following function. So what I can do is I can write any sine, cos, tan, trig function in the following form. So in this case, sine of n of x minus b plus c. Alright, and a is going to be my amplitude, and the period is going to be defined by n. So the period of any sine or cos is 2 pi on n. So for this function, we can see that 4 is the amplitude, so my amplitude equals 4. My period is equal to 2 pi on n, and in this case, our n value is a third. So hopefully you can see that that's divided through by 3, which is equivalent to 2 pi on 1 times 3 on 1, which is just 6 pi. So that question was reasonably well done by most people. 2 out of every 3 got that question completely correct. The next question, however, was done a little bit more poorly, with only about 40% of kids getting full marks. And this is the sort of question that appears year in, year out. So what we want to do with this equation when we're trying to solve root 3 sine x equals cos x is to get only one trig function involved. And the way that we're going to do that is we're going to divide through by cos x from both sides. And what this does is it brings in the tangent function. So we know that sine divided by cos is the tangent function. So what I can do is I can rewrite this equation to be root 3 tan of x equals 1. Alright, so the sine x on cos x becomes this tan x function, and cos x divided by cos x just gives me 1. So the next thing I can do is I can divide through by the root 3. So divide by root 3, divide by root 3. And I simply get that the equation I'm trying to solve is just tan of x equals positive 1 on root 3. So this is just a pretty simple case now of finding our reference angle and then solving the equation. So my reference angle is the angle that gives me 1 on root 3 for tan of x. So we know that tan is opposite on adjacent, and hopefully you guys will remember that one of our triangles is the 1 root 3 2 side lengths with a 30-degree angle in here and a 60-degree angle in here. So that's something you need to commit to memory for your exam. So to get opposite on adjacent equal 1 on root 3, we're dealing with this 30 degrees here. So my reference angle, which I might call theta, equals 30 degrees, or more usefully, it's going to be pi on 6 radians. Now all we need to do is work out when is sine positive, because technically there's a little positive sign there. So for this we use our cast model, so CAST, and this tells us that tan is positive in the first and the third quadrants. So the symmetry here is just theta and pi plus theta. So now I can rewrite this as being the same as x equals theta and pi plus theta. But previously I worked out that theta was just pi on 6. So I've got pi on 6 and pi plus pi on 6, which is the same as pi on 6 and 7 pi on 6. So the last issue with this is that we've been given a specified domain. So x is between negative pi and pi. So hopefully you've all spotted that this is outside the domain. So what we can do is we can now just add or subtract a period onto the solution, pi on 6, to find the next one going backwards. So what I'm going to do is I'm going to subtract off a period. And the period of a tangent function is just pi on n, where we discussed that n's that coefficient that sits inside here. So technically n equals 1, so I can write this as just being pi. So pi divided by 1 is just pi. So the other solution that I'm looking for is x equals negative 5 pi on 6 and pi on 6. So the negative 5 pi on 6 was found by just subtracting 6 pi on 6 off this first solution that we found. So hopefully you can see that both of these are inside the accepted domain that we want, and we've now got all the solutions to this equation.